You are in the meeting now.
Recording in progress.
Hey, good morning, everybody. How are y'all today? Thumbs up from at least one person. All right. Um, I hope everybody is doing well. Excuse me. So today we are doing our review for Unit 2. Um, Exam will be on two parts, just like the last exam. Part 1 will be on Wednesday, Part 2 will be on Friday. Um, I graded quizzes over the maybe it was Thursday. I graded those quizzes, so you should have all the quizzes that we've had and keys up on Blackboard, so you can go back and refer to those quizzes for some additional information. Um, but as I said, and the keys are up as well, so you can compare your quiz to the quiz key. Um, The purpose of today is to address your questions um, from the exam for Unit 2. Unit 2 review. Um, and so that's what I'm here to do today. So um, the floor is yours, so to speak. What can I help you with in terms of material over Unit 2? Are there any questions that we need to address?
Can you do number 13?
Let's take a look at problem number 13. One of my favorite types of questions. Alright, one of my favorite types of questions. Alright, so first of all, when I say write the equation of the line, the format that this answer must be in is y is equal to mx plus b. That's the format that we're looking for. Why do we want this format? Because under this format, I can easily graph the line. Okay, so we want it under this format. Now, I'm given a point that this line goes through. So typically, anytime that I'm told to find the equation of a line given a point, I'm going to use my point slope equation, which is y minus y1 is equal to m times x minus x1. And I could go ahead and start plugging in some values here. We have x1 and y1. So we could say y minus 2 is equal to m times x minus a negative 7. But the thing that I don't know yet is m, my slope. I don't have anything to plug in for that. So that's where the rest of this problem comes into play. It is perpendicular to this equation. So when I look at this equation, y equals negative 4x plus 19, I know that since it's in this format of the slope-intercept form, y equals mx plus b, I know that m for this line, we'll call this m1, is equal to negative 4. That's the slope of this line up here. But we want the perpendicular slope, we'll call that m2. And remember, perpendicular slope, we're doing a negative reciprocal or a negative flip. So the reciprocal of 4 is 1 over 4. The negative or the opposite of negative 4 is going to be positive, so the perpendicular slope is going to be 1 over 4. Alright, so to the lady that asked about this question, does that make sense why the perpendicular slope of negative 4 is 1 over 4? We all good there?
Yes, sir.
Okay, so at this point, we have our point that we've already plugged in. We need slope, and this is the slope that we're going to plug in here. So concluding our example, we have y minus 2 is equal to 1/4 times an x plus 7 so that's y minus 2 is equal to 1/4 x plus 7/4. I want to add 2 to both sides, but I'm going to change that 2 to a 8 over 2. 8 over 4. I just multiplied 2 by 4 over 4, so I now have a common denominator, and this gives us y is equal to 1/4 x plus 15/4. Now, here's what I would do at this point. You don't have a graphing utensil. I mean, you could graph this, but the problem is you have this really funky y-intercept of 15/4. So what I would do in order to verify my work is I would check. Now, it should be easy to see that we are dealing with a perpendicular slope. Coming back up here to this equation, slope is negative 1/4, so the perpendicular slope is 1 over 4. Now, how do we know that this line is actually going through this point? Well, we're going to plug in the point -7, 2. So we should get that 2 is equal to 1/4 of a -7 plus 15/4. So that's going to be -7/4 plus 15/4. -7 plus 15 is a positive 8/4, and 8/4 is 2. So 2 is equal to 2. It checks out. So I've verified that this point that's supposed to go through does indeed actually work for this equation. So here is our final answer. Y is equal to 1/4 x plus 15/4. Okay, does that make sense?
Yes, sir. Thank you.
Alright, what else can we look at? Anything?
Can we do number 9?
Certainly. Difference quotient. Let's see what. Okay, number 9. We are given that f of x is equal to 3 times an x squared minus 2x plus 5, and we are told to find the difference quotient. Okay, so the difference quotient is this expression f of x plus h minus f of x all over h. So we want to find the difference quotient for this f of x function. So again, I like to think of this in 3 parts. There's the f of x plus h. Here is our f of x, which is already given to us right here. And then we have our h. So the first thing I'm going to do is I'm going to find that f of x plus h. So f of x plus h is telling me to plug in x plus h for all of my x's. So think about it like this. Everywhere you see an x, you're going to replace that x with x plus h. So instead of plugging in a number like 4 or whatever, you're plugging in x plus h. So when I think about the issues that come up with a problem like this, one is the order of operations. Order of operations says that we need to do exponents first. Don't distribute the 3 just yet. Do the exponents first. And I told y'all to take note to memorize that x plus h squared is equal to x squared plus a 2xh plus an h squared. Just memorize that. Know that. Know how to FOIL x plus h by itself to get this. So this becomes 3 times an x squared plus a 2xh plus h squared. Then we can distribute the negative 2. Make sure you distribute the negative with the 2. So minus 2x minus 2h plus 5. And now I'll go ahead and distribute the 3. So that's going to become a 3x squared plus a 6xh plus a 3h squared minus 2x minus 2h plus 5. And that is our f of x plus h. So now it's just a matter of plugging everything in. So I'll keep everything color-coded. We have 3x squared.
You are in the meeting now.
Recording
Plus
in progress.
6xh plus a 3h squared minus 2x minus 2h plus 5. Now, I want to come back up to our difference quotient. That minus sign right there. That minus sign is going to change the sign of all of my f of x terms. So we actually get a minus 3x squared plus 2x minus 5. Because that minus sign, again, will distribute to all 3 terms of f of x. And this is all over one last time for color, h. Alright, so at this point, stuff starts happening. At this point, first of all, things start canceling out. So the 3x squared cancels out with a negative 3x squared. The negative 2x cancels out with a positive 2x, and then positive 5 cancels out with a negative 5. At this point, all that you should have left in the numerator are things that have an h with them. So I'm going to just come up here. So what do we have left? We have a 6xh plus a 3h squared minus 2h all over h. And at this point, everything that has an h, or every single term has an h in it, and those h's will cancel out with the h in your denominator. The reason being, because you can factor out an h, leaves you with 6x plus a 3h minus 2 all over h. The h's cancel out, leaving you with a 6x plus a 3h minus 2. Oftentimes, you might see someone do something like this. They'll say, okay, this h cancels out, that one of those h's cancel out, and that h cancels out there, 6x plus 3h minus 2. Every single h up top will cancel out with every single single H up top will cancel out with the H down below. And that is problem number 9. Sudan, glad to see y'all again. Y'all canceled out for a second. Glad you are back. Alright, so to the person that asked about number 9, does that make sense? How to go through and find the difference quotient for a given function?
Yes, sir. Thank you.
You're welcome. What else can we look at?
Can we do 18A?
18A. Sudan, I got an email. Let me respond to this email from Miss Cunningham real quick.
We can't see you.
Yeah, I know y'all can't see me. And I don't know what to tell you. And our technology, let me take just 2 seconds. It'll be more like 30 seconds to go to see if someone is here that can talk to Region 17 about this issue. I'll be right back. Speaking specifically to Sudan, both people who I could bring this issue to, are not here today. So I don't know what to tell you in terms of why you can't see me. It's just problems with technology. The video of today's recording should get posted to Blackboard. I will email one of those people to make sure that it does get posted to Blackboard. So anything that you can't see, you will see on that video recording, and it should get posted at some point today, hopefully tomorrow. Sorry, I can't do any. Sorry. All right, back to problem number 18A. 18A is to determine whether the functions are odd, even, or neither. So, let me just give you let's just do some reminders of what is odd, even, what is odd and even. Let's start off with even. Even functions are going to be symmetric about the y-axis. So that means that they're going to look something like this. If this is our x-axis or y-axis, they're gonna look something like this, like a parabola. Or they could have more symmetry. They could be something that does this. Both of those functions are symmetric about the y-axis. And something else that's particular about these even functions is that they're all going to be of the format f of x is equal to x squared, or x to the fourth, or x to the sixth, so forth and so forth and so forth. So an example that would be not symmetric would be f of x is equal to x squared plus another x. As soon as you add another x in there, what that other x is actually going to end up doing, it's going to shift the graph left or right. So it's not going to become even anymore. This is going to shift the graph left or right. And so it's not going to become symmetric about the y-axis anymore. So when we look at problem number 18a, let's just go ahead and, well, let me go ahead and finish my talk. Odd functions are symmetric about the origin. So they're going to look something like this. That's called symmetric about the origin. The idea is that if you mirror image the graph on the y-axis, you get this, and then you mirror image the graph on the x-axis, you get this. So that's symmetric about the origin. Another one could be something like, that does something more like this. That would be symmetric about the origin. And they all have the format of f of x is equal to, we'll start off with x, or x to the third, or x to the fifth, or x to the seventh. Notice that they have odd exponents. Something that's not would be f of x is equal to x to the third plus an x squared. So that plus x squared is going to have a change on the symmetry of this initial function. So when we look at problem number 18a, that is f of x is equal to 8x to the 10th minus a 4x to the 5th plus a 3x squared minus 6x plus 1. You know, if I was looking at just this part of the function, the 8x to the 10th, that would be even because my exponent's even. Or if I was just looking at this part of the function right there, negative 4x to the 5th, that would be odd because the 5 is odd. But as soon as we start adding all these other x terms, you have an even term, you have an odd term, you have another even term, an odd, and you have this constant way over there, that's going to throw everything way out of balance. It's not going to be symmetrical anymore. So this is neither even nor odd. So the only time that you're going to have an even function or an odd function is if you just have, for this example, x squared, there's nothing else attached to it. I should give a counter example. You could have x squared plus 2 because what that's gonna do is that's just going to raise your graph up 2 units, like that. 1, 2, it's still symmetrical. So you could have x plus a constant. Even down here you could have f of x is equal to x to the third minus 4, because what that will do is, or x to the third minus 4, is that will just, actually no, because that wouldn't be symmetrical about the origin anymore. So, never mind about that example. So, that's what makes functions even or odd. So 18a is neither. Just wrapping this up, b is y is equal to 2 to the x. So since the exponent is 1, we can already say that since that's odd, this is an odd function, and you could even graph this real quickly if you wanted to. You're starting here at the origin, you're going up 2 over 1, up 2 over 1, you're going down 2 over 1, down 2 over 1, and so you had this symmetry about the origin. And problem number C, you're given a graph that looks something like this. And that would be symmetrical about the y-axis, so this would be even. Okay, I hope that helps explain problem number 18a. I know you only asked about 18a, but I went ahead and talked about b and c. Alright, what else can we look at? What else can we look at?
Can we do 22?
Could you say it one more time, please?
22?
22. Okay, so problem number 22, what we want to do is we want to rewrite in the form x plus h, or excuse me, x minus h quantity squared plus y minus k quantity squared is equal to r squared. That's what we're trying to get to. And to do this, we are going to complete the square. We are going to go through and complete the square. So let's go through and do this. So the first thing that I want to do is I want to get 4 to the other side of my equation by subtracting 4. And at the same time, I'm going to do some reordering of terms. I'm going to put x squared minus 4x plus y squared plus 6y equals negative 4. And at this point, what we want to do is we want to go through and we want to add b over to quantity squared. And we got to do this for the x's and the y's. So for my x's, b over 2 quantity squared is equal to, this is our b, so that's going to be negative 4 over 2 quantity squared, which is equal to negative 2 quantity squared, which is equal to 4. And for my y's, 6 is our b, so we're going to have 6 over 2 quantity squared, which is 3 quantity squared, which is equal to 9. So we have to go through and add 4 and 9 to both sides of the equation. We have to now have x squared minus 4x plus 4 plus y squared plus 6y plus 9 is equal to negative 4 plus 4 plus 9. You have to add the, I'm going to just underline this. Here's the 4 that we added, there's the 4 that we added to both sides, and here's the 9 that we added to both sides. Okay, and at this point, what we can do is we can go through and factor. Alright, now, something to remember here is that what we have is x squared plus a bx plus this quantity b over 2 quantity squared. And the factored form of this is always x plus the b over 2. So if you can memorize that, that makes this next step really easy. So the b over 2 for my x's was negative 4 over 2, so it ended up being negative 2. So the factored form of this trinomial is x minus 2 quantity squared. Since the b over 2 for my y's, negative 6 over 2 was 3, the factored form of my y's is y plus 3 quantity squared equals negative 4 plus 4 is 0, plus 9 is 9. So, complete the square and write this equation of the circle in center radius form. Alright, so done. Center radius form. Now, taking an extra step here, A, what is the center? The center is HK. So remember our format that we're looking to, we want to get to this point, x minus h quantity squared, y minus k quantity squared. So HK is going to be 2, negative 3. You have x minus h, so 2 is h. I could rewrite this as y minus a negative 3 quantity squared, so you have y minus negative 3, so there's my center. What's my radius? That's part B. Remember, the format is that r squared is equal to 9. So that means that r is equal to 3. So there's my radius. I could tell you to graph this. Alright, so let's see, 2, negative 3. Alright, so let's graph this real quickly. I know I'm going above and beyond the review, but I'm trying to potentially capture other problems. So here's our center at 2, negative 3. Since our radius is 3, we're going to go up 3, 1, 2, 3. We're going to go to the right 3, 1, 2, 3. So that's 1, 2, that's at 5. We're going to go down 3, 1, 2, 3. So we're now at -6. We're going to go to the left 3, 1, 2, 3. We're at -1. Draw our, doesn't have to be perfect, but there's our circle. And then I could ask further questions. D, function? No, because it fails the vertical line test. But we can talk about things like the domain. So the domain of this function is going to be your x's from here to here. So our domain is going to be from -1 to 5. And f, if I say what is our range, well, our range is going to be the y values from here to here, and that would be -6 to 0. Okay, another one of my favorite type of problems. Alright, what else can we look at?
Can we go over 27?
27. Alright, use the remainder theorem to find f at 3. So the remainder theorem basically is going to be saying to use synthetic division with a equal to 3, our f of x right there. And the idea is that here's the idea that we're trying to do. The idea is that the remainder will be f at 3. So if I give you a problem like this, you have to use the synthetic division, and you have to show me that the remainder will be f at 3. You can't just plug in f at 3 at your calculator and do this. You have to show me the work using the remainder theorem. So here we go. Synthetic division. So here's our upside down division box. Let's put our coefficients. 1, -7, 5, -6. A is going to be 3. And so now we play the synthetic division game. So bring down the first coefficient, 1. Then you're going to do 1 times 3. So that's going to be 3, and then you add. So that's going to be a -4. Then you multiply again. -4 times 3 is going to be a -12. And we add. -12 plus 5 is going to be a -7. And we multiply again. So 3 times -7 is going to be a -21. We add. And I get a -27. Now, as a reminder, we have x to the third, x squared, x are constant, everything drops a degree, so we have x squared, x are constant, and our remainder. So, what this is saying is, since that negative 27 is our remainder, we can now declare that f at 3 is equal to a negative 27. F at 3 is equal to a negative 27. Now, this is what I want to see for full credit here. Now, by all means, check your work. I hope I got this right. Check. So I would go through and plug in 3 into my function. So that's going to be 3 to the third minus 7 times 3 squared plus 5 times 3 minus 6. Alright, so you could use your calculator. Let's do this. 27 minus 7 times 9 plus 15 minus 6. So that's 27 minus 63 plus 15 minus 6. Let's see, let's just make this easier. So 27, 15, that's going to be a 42 minus a 69, and that is negative 27. There's my check, and I can see that I get the same thing. Alright, so does that make sense about the remainder theorem?
Yes, sir.
Good. While I'm thinking about it, synthetic
Your
division.
conference is scheduled to end in 2 minutes.
So, divided by x minus 2. Remember that it's the 2 that gets brought out in front, and then here are your coefficients. It's not negative 2, it's 2, because we have to think about dividing by x minus a. So since you have x minus a is equal to 2, this is where we put a. But if you had f of x divided by, let's say, an x plus 3, since I can rewrite this as x minus a negative 3, that would mean that a is equal to negative 3. So then you would have negative 3 out here, and then your coefficients. So remember what your a is. For x minus 2, a is 2, but for x plus 3, your a is actually negative 3. Remember what that means. All right. So, closing out our time together. Exam 1, part 1 is on Wednesday, part 2 is on Friday. I'll be available by email.
Your conference is now over. Goodbye.
So if you have any questions, shoot me an email. Student, I hope we get things worked out with the technology stuff. Sorry about it. Bye. This is Jared. Hey Kenneth, how are you today? I'm doing well. Oh, oh, okay, well, thank you very much, Kenneth. I'll try to make it by today. If not today, it'll be tomorrow. Alright, thank you, Kenneth.